Hello everyone and welcome. In this short video, you will see how to identify and fix storage skew issue in IBM PureData System for analytics. Skew is often caused a single query or a system-wide performance problem. It indicates an unbalanced amount of work taking place one or a subset of all active data slices. There are two different kinds of skewing that can negatively impact the system performance. First one is a storage related, also known as table or express queue. When data is loaded to a table, the rows are distributed to a particular data slice based on the distribution key, assuming distribution is not defined as random. The data slices holding a larger count of table rows will generally work longer, harder, and consume more resource to complete its job. These data slices can become a performance bottleneck for the queries. This uneven distribution of table rows is known as storage skew. A query will need to process table data in various ways to produce the final result set. Along the way, NPS creates intermediate tables to filter projects, sort, and aggregate data, along with broadcasting and redistribute data. This intermediate table may produce an uneven distribution which can negatively impact the query performance. This kind of uneven data distribution called as processing skew. Data distributions and performance are interrelated. A storage skew is the result of bad distribution, and it occurs when data is co-located in one or few data slices. In a massively parallel processing system like NPS, it is essential that every data slice performs same amount of work. Because a query completes only when all the data slices completed its part of the work. Therefore, a distribution method that distributes data evenly across all data slices is the single most important factor that can influence overall performance. Storage skew is very straightforward to identify. The goal is to find those tables that have significant gap in disk space used between the largest data slice and the smallest. There are quite a few ways to identify storage skew. We will take a look at some of these common indicators. Let's start with the nzds command. It shows how much storage space is used by each data slice. Look for data slice with highest percentage used. In this example, data slice 3 is 100% used. Rest of other data slices are around 84% used. It indicates there is a storage skew in data slice 3. You can get more information about storage skew using nzskew command. This will show how the data distribute across data slices. The top part of this command output will show the overall SPU disk utilization. In this section, storage used percentage part can help you to identify if there is a big difference between min, max, and average storage used that can be an indication of storage skew. The bottom section of the nzskew command output will list all tables on the system in which the largest data slice has 100 MB more disk used than the smallest one. The 100 MB value is the default, but it can be override by using the amount parameter with the nzskew command. Try to find out which table has highest min max skew value and focus on large tables only in terms of size. The skew ratio is expressed as a range. At the low end, it could be 0.0, which indicates one of the data slices stores no data for this table. At the high end, the value could match the total number of data slices in the system. A table that is used exactly the same amount of storage across all data slices will have a ratio of 1:1. The dslice column indicates the data slice with the maximum amount of storage used. In this example, the skew ratio column shows table 2 and table 4 have a high difference in range value. However, size-wise, table 2 is really small, which can be ignored, but table 4 needs to address for storage skew. The NZ record skew is another command that checks skew for a particular table. It shows kind of similar information as NZ skew command. The spoos column represents number of spoos that table spread across. The mean average max column shows number of rows per spoo for each table. The skew ratio expressed as a range, similar as the NZ skew command. A range of 1:1 would indicate no skew at all. In general, the larger the table, the smaller you want the skew ratio to be. Running this command against all tables in database can take very large amount of time because it does the full table scan. It would be better you run NZ skew first to find out the table having a storage skew based on the VD spoo zone map table. Then use the NZ record skew command to view the skewness of an individual table. Next is NZ responders command. It shows how a query snippet is responding against data slices as it's running. This command can be used for detecting storage skew as well as processing skew. The busy column shows number of data slices are busy running the query snippet. If the busy shows same as the total number of data slices in the system, it indicates things are running normally because query snippets running across all the data slices. That is the case with the plan ID 86 here. But the plan ID 83 is only running on one data slice. It could be an issue if that snippet is running for a longer period. The data slice column lists individual data slice number, those still running query snippets. With the plan ID 83, you can see only one data slice is busy, which is data slice 13. It is still busy after other data slices have finished their work. This snippet cannot complete until all data slices are finished. Thus, the query waits for this one data slice before it can progress to the next snippet. It can indicate of a storage skew in the data slice 13. Keep in mind, the NZ responders is often the most useful tool available to identify potential skew issue. But this command can report lagging data slices that occur other than skew, such as topology imbalance, slow disk failure, etc. You can identify storage skew from the plan file also. The table information in detail line shows mean average max size of table that associated with each query snippet. It shows the real size without the processing data. If there is no difference in mean average and max, it displays only one value. Anytime you see difference between the mean average and max value, it indicates some storage skew. In this example, snippet 2 having biggest difference in mean and average value, you need to check the table associated with the snippet 2 and take the corrective action. There are some other mechanisms also to identify storage skew, like query plan output, Netezza administrator GUI, event manager, etc. But we are leaving those for some other time. Here is list of things that can help you to fix storage skew issue. Improper data distribution is the main reason of storage skew. So when you selecting distribution key, consider a column that distribute rows evenly across all data slices. Choose as few columns as possible. Even when system allows you to select up to 4 columns as the distribution key, it is better to pick just one. Combining a few columns together makes sense only if we join on all of them. Choose a column that is often used to join to other tables, since it can eliminate data movement. You must use a distribution key with fact tables, otherwise data movement needed, and performance can be affected. But it is okay to distribute small table as a random. A good candidate for distribution key is a column with high cardinality. You can use the NZ table analyze command to analyze column that could be good candidate for the distribution key. Hope this video gives you some idea to tackle skew in NPS. Thank you for watching. Goodbye until next time.